What's up, everybody? My name is Paul Megan. I'm here to talk about best practices for building a data lake on Amazon S3. I'm going to take you through a number of topics today, having to do with building out just a massive scale data lake on S3. Before I do that, though, I'm going to talk a little bit about what a data lake means and what it means to us specifically in the context of this presentation, right? So data lake really has two fundamental characteristics. The first is that it's usually huge. You're aggregating a bunch of data from all around the enterprise into a single spot so that you can run analytics on it, so you can drive workflows off of it, so that you can just extract as much value as possible out of all the data that exists in your environment. The second characteristic is that it's shared. Since you're aggregating all of this data into one place, you typically have to have a bunch of stakeholders sort of coming in and out and having access to various parts of the lake so that you can run analytics, so that you can put data in through various sources. You just have a lot of stakeholders accessing this single big shared data set, right? So those are the two fundamental characteristics that we think about when we think about what it takes to actually store a data lake. Now, there are plenty of other folks here within AWS that have various different sort of roles to play in making a data lake run, like the analytics services or the ingest services, and we'll talk about a bunch of those today. But from a storage perspective, those are the two characteristics that we're kind of most concerned about and that we'll talk about the most as we go through the presentation today. Okay. The first thing that I want to talk about, though, is just some of the core characteristics of S3 that make it very well suited for running a data lake on top of. The first thing has to do with our inherent sort of durability, availability, and scale. And these come out of the box with S3. You don't have to do anything to get these fundamental characteristics, and they just are there for you all the time. It's one of the things that's most magical about S3 really is that it's that sort of regional service. We distribute data across many systems and across many sort of physical buildings within an AWS region, so that you get out of the box this very wide, scalable, and reliable storage that you can run your applications against. The second thing is around the security and compliance that are associated with S3. So S3 is secure by default, and we give you a bunch of tools and features that you can use to go tailor and customize your security posture so that it fits exactly against the rules of the business that you face. Third thing is around performance. S3 is an extremely distributed system. You can scale out basically as far as you want to go. And so really going wide against S3, spinning up many threads in many machines, it really means you can really achieve high rates of performance. We have many customers running a transaction per second rates like way up there in the hundreds of thousands. And so there's a lot you can do on performance as well that is pretty unique to S3. It's also a very low cost platform. We have a bunch of storage classes, which we'll talk about, so that you can really optimize the storage class that meets the needs of the workload that you're running. We also give you some analytics tools that you can go deploy so that you can see which storage classes your workloads kind of fit on, right? So that you can optimize and get as low storage cost as possible for your workloads. And the last thing is just sort of a broad ecosystem integration. The S3 API is effectively sort of the de facto standard for object storage in the industry. And so tons and tons of third-party software packages, as well as AWS services, are built to run against S3. So when you put your data there, you have a wide variety of potential software capabilities that you can go deploy and do stuff with that data that once it's kind of sitting in the data lake, right? So these are all sort of fundamental core characteristics that come out of the box with S3. You don't have to do anything to get any of this stuff. It's just sort of there, right? And so that's a great starting place when you're looking to go build a data lake to just kind of have all of these characteristics natively right from the beginning. Okay. So what I'm going to do now for the rest of the presentation is kind of take you through the typical steps associated with building and running a data lake. And I'll try and touch on a bunch of features within S3 as well as around AWS that you can use. And I'm going to kind of use this sort of high level data lake architecture as kind of the signposts that we'll use to kind of step through all these various capabilities within AWS. Okay. First, we're going to talk about storage setup, some things to think about before you get started. How you want to get your storage going to make sure that you kind of thought through all the features and options that you need in order to be successful with a data lake deployment. Talk about ingest, how to do that, how to bring a bunch of data into storage. We've got a bunch of tools features, AWS services that can help you do that. In the typical data lake process, a lot of times there's a cleansing prep process to sort of transact and prepare data to be analyzed within the lake. It's sort of a unique part of the data lake process. So we'll talk about some options that we have there. Once your data is prepped and ready to go, it needs to be sitting in a place that is kind of secured according to the rules of the business. So we'll talk about S3 security and some of the compliance capabilities that we have in S3. And finally, we'll talk about making data available for analytics at the end of the process. And that's sort of the goal, right? Is to make useful data available so that analytics applications can deliver value back to the business. Okay, so that's the order that we're going to go in pretty quickly and talk about each one of these topics. All right. So from a storage configuration perspective, typically the first thing that we talk about when we're talking to customers about running S3 for any use case has to do with the storage classes that they want to run on, right? Storage classes within S3 are kind of storage tiers, and they all have sort of a price to performance trade-off, right? That's typically the way to think about a storage class, right? Data that is intended for sort of long-term, rarely accessed data sets typically has a low storage cost, with a higher cost to retrieve data out of storage, whereas storage classes intended for more hot, active workloads have a higher storage cost but a lower retrieval cost, right? So that's sort of the balance that you always want to strike. You want to think about what are my access patterns and where do I fall for any given data set, sort of on that continuum of heat to sort of heat to capacity, right? To cost, right? So what I'm going to do is take you through a few storage classes here and sort of in the data lake context. We'll talk about each of those steps that I talked about on the previous slide in terms of the data lake process, and we'll talk about which storage class fits for each one of those steps. So the first thing that we want to, the first thing that is typically done when customers are running data lakes is they're ingesting data, right? They're ingesting it raw from IoT devices or out of databases or through a wide range of data sources. They're bringing that data in raw, and then they're often ETLing that data into what is sort of a common usable format that makes a lot of sense for the analytics applications, right? So you have this sort of processing pipeline that is often present in the early stages of the data lake process. And these sort of active or early pipelines often have small log files that are coming in bit by bit. This data is often short-lived. Overwrites are often done. In short, there's a bunch of churn, right? This is really hot, churny data as it's prepped and ingested and transformed and all that, and getting ready for the sort of the longer-lived format that the data will ultimately live in to be analyzed, right? So for this sort of hot, churny workload, we recommend S3 Standard, which is sort of the storage class that is the most broadest, widely applicable storage class out there. And it really is intended for that shorter-lived, hotter workload. There are very low retrieval fees, if any, and it's just very well suited for that sort of general purpose, high transaction type of workload, okay? So once the data is transformed, right, and it's ready to be analyzed, then we often recommend that customers take a look at our intelligent tiering storage class. And this is sort of that production data lake, right? My sort of prepared data. And the reason that we like this is what intelligent tiering is really great for. It's really great for workloads that have changing access patterns over time. What intelligent tiering does is it effectively puts your data in a frequently accessed tier when it is being accessed, when it's fresh. And then once your application stops accessing data, after 30 days, intelligent tiering will tier down to an infrequent access tier, those data sets. When it tiers down, it gives you a lower storage price in the process, right? So for workloads that start off hot and then cool off over time, intelligent tiering is a great fit because you automatically get storage savings as the data cools off. You don't have to do anything, right? Intelligent tiering does that intelligently for you, right? Okay, so that's kind of why it makes a lot of sense to have that prepared data on intelligent tiering. Now, eventually, what happens with just about any data set on the planet is it gets cooled off and goes into a state where it's rarely, if ever, accessed, right? So for those cold data sets, in the lake, we really have two options. We have an online cool option where this is sort of standard infrequent access or standard one zone infrequent access. These two infrequent access storage classes are very low storage cost with a higher retrieval rate. They deliver millisecond latencies, and so they're really for those cases where you have cold data sets. They're rarely, if ever, accessed, but when they are accessed, they need to be accessed immediately, right? These data sets in that sort of category really belong in the sort of online cool set of storage classes. Again, that's standard infrequent access and one zone infrequent access. The last category of data of storage class that we have are for historical data. These are our archive storage classes. They're called S3 Glacier and S3 Glacier Deep Archive. These storage classes are for historical data sets, things that you probably aren't going to use. And if you are going to use, you're okay waiting sort of minutes or hours or even days to get that data back, right? So it's not online. There isn't sort of millisecond latencies in order to get that stuff back. Right, so you can sort of envision, like from start to finish, the life cycle of data as it's being ingested into the data lake, landing on S3 standard, being prepared for analytics, landing in intelligent tiering, processed, analyzed, and then over time moved off into these colder storage classes in order to save you money on your storage bill. So that's the overall sort of S3 storage class portfolio in the sort of framing and context of a data lake workflow. Okay, the next thing to talk about really is around performance. Once your data is in S3, there still are and your storage class is chosen. There still are performance considerations that you wanna think about. All right, our performance limits are based on a per prefix basis. So every prefix within S3 out of the box gets 3,500 puts per second or 5,500 gets per second. If you have a mixed sort of put-get ratio, you land somewhere in that range, between 3,500 and 5,500, depending on the balance, right? What percentage is put, what percentage is get, okay? If you're bumping up against those limits within a prefix, S3 has the capability in the background to sort of partition your bucket in such a way that your capacity, your TPS capacity, will expand over time. But it is important to kind of keep in mind your key naming structure and keep this 3,500 put, 5,500 get limits in mind when you're laying out sort of where your data goes within the key space within your bucket, right? Especially when you're talking about extremely busy workloads, where you're gonna do sort of bursty, sudden increases in TPS. You especially want to keep in mind sort of this per prefix concept as you kind of lay out the names of your objects and lay out your key space. There are entire reInvent presentations all about how to scale S3 performance, about how to really go wide on top of S3. And if you're going to really push the limits from a TPS perspective, from a transaction per second perspective, really encourage you to dive deeper on this topic and carefully think through all of the performance considerations if you really want to go wide and push the service to its limits. Okay. Another thing to really keep in mind is the object size. So in general, we like larger objects, right? So 2 to 16 megabytes in that range is a nice sweet spot for us. And the reason that we like those objects is it allows you sort of less connections, sort of less requests to make to S3. It's like a nice aggregation, allows you to stream in a sort of at a good rate. Also allows you to perform more parallel sort of byte range reads against larger objects, right? And so keep that in mind as you're sort of thinking about your ETL processes, as you're bringing data into your data lake. You don't want to end up with, if you can avoid it, it's not always possible, but you want to try and avoid ending up with millions and billions of teeny tiny objects. That's just going to generate a bunch of overhead for you. And it's also going to, as a side benefit, a side detriment, sort of affect your costs, right? Because many of our storage management functionality is charged on a per object basis, right? So getting you sort of within that 2 to 16 megabyte sweet spot in terms of object size will make your life easier in general. You want to always be thinking about that. The format of the object also matters a lot for your app. We get a lot of questions about performance tuning from S3, on top of S3, and we often point customers back to some of these basics that the type of object, the format of the object can make a big difference for how your application actually will perform on top of S3. The last thing that I want to call out on performance is just to always make sure you're on the latest SDKs and software versions. We're constantly improving our SDKs. We're constantly releasing new versions of the software and working backwards from feedback that we're getting from customers. And a lot of times performance enhancements will kind of sneak out there without a big announcement, without a lot of fanfare. So we always encourage customers, if you can, to stay current on the most current SDK available that you can run with your app. Another option in terms of increasing performance for S3 is to take a look at S3 Select. What S3 Select is it's a read API, sort of first class API within S3. Instead of a normal get, though, you're able to read off of S3 objects with just normal S3 SQL semantics, right? So you're able to run a SQL select call against an S3 object. And this can speed you up considerably if you just need a tiny little slice of an object. And you can just run that sort of optimized select statement against that CSV file, for example, and just bring back that one row. That's a lot less to bring back over the network. There's a lot less for your app to process. And it can speed you up considerably if you have that sort of CSV, JSON, or Parquet that you want to go just basically run SQL queries against. Another thing that we like to mention just as a general sort of storage setup, from a general storage setup perspective, is to really think about, before you start to load up your data lake, really think about data management and how you're going to manage that data once it's there. You're touching all of your data as you're bringing it into the lake, and so it's nice to kind of think ahead on what you might want to do with your data as you're sticking it in. Specifically, I always encourage customers to take a look at object tagging on Ingest. This way, if you want to use features like lifecycle policies or replication downstream to either tier your data or manage retention periods, or to replicate to a second AWS region, if you've tagged your data with object tags as it's come in to the data lake, you've got some additional metadata that you can go write policies against, and it can really help you to write much more effective replication and lifecycle policies downstream. Now, if you don't do that and you need to go apply tags to millions or billions of objects that are always in the lake, that are already in the lake, we have S3 batch operations to help you with that. Batch operations is a fully fledged batch processing system within S3. And what it does really well is it does one thing a million times over, right? No matter how simple that one thing is in computer science, doing stuff a million or a billion times is kind of tough, right? Batch operations manages things like retries, avoiding throttling, all of that stuff. So if you wanted to apply a set of tags to a billion objects, batch operations is your tool within S3 to go do that. Okay, so just a few storage management tips to kind of think through on the front end, just to kind of, so that you find yourself with petabytes of data in your data lake. You'll be in a better spot in terms of how to manage that stuff. Okay. All right. So that is my overall sort of storage setup pitch. Again, we talked about storage classes, we talked about performance, and we talked about some storage management considerations that you want to take into account before you really get going loading up your data lake. Okay, so once you kind of have a strategy along those three axes, you want to think about, like, how am I going to ingest this stuff? How am I going to prep it for analytics, right? On the ingest side, there are a ton of options for getting data into S3. More, and seems like more and more options every single day. I think about those options in terms of three general camps: sort of real-time processing or real-time ingest into S3. This is for stuff like IoT, sensor data, clickstream data, these sorts of data sources that are coming in on a very constant basis all the time. We have a bunch of tools within AWS to kind of make that happen. These are mostly sort of AWS services in the Kinesis family to kind of deal with those ongoing real-time data streams into S3. There's actually a lot you can do there. We'll talk about that in an upcoming slide or two. The second category that I always think about when I'm thinking about ingesting data into S3 are those sort of big batch jobs to bring batches of data on a nightly or hourly or weekly or whatever basis, right? So we got a bunch of stuff there as well. We have the storage gateway family, for example, that is awesome at taking database dumps from on-prem, for example, being able to just dump out data sources periodically onto a gateway and have that stuff just magically appear into S3 for you to go manipulate and work with. That's kind of on the batch side. And then we have bulk options as well, right? So things like Snowball Edge, and even the massive Snowmobile that can bring a ton of data into S3. When you really need to bring a lot, the best way to do that is just load it up all on a physical device within your premises and just send it to us, and we'll load it into S3 for you, right? So again, wide range of options for ingest along these three axes: real-time, batch, and bulk. And you really want to think through kind of which category you land in as you're choosing one of those three categories. Okay, now I want to talk a little bit about some patterns that customers often implement in order to actually ingest and transform their data as it comes into S3. And I talked a little bit about the Kinesis family. Kinesis does some awesome stuff to help you get data effectively sort of prepped and landed in S3. It not only does aggregation as streams are coming in, and allows you to sort of set those and manage those streams up, manage those streams as they're coming in. It also allows you to do things like run analytics on the streams themselves. So bringing analytics as close to your data sources as possible, so that you can get much more sort of real-time insight against data as it's coming in. So you can be feeding Spark on a near real-time basis and getting those insights very quickly. And it also allows you to pass down to Firehose, which does the work of aggregating data and landing data actually in S3 buckets in a way that makes sense, not only from an S3 storage perspective, but also from the perspective of being able to do stuff with that data later. I talked about sort of ideal object sizes and key layouts and stuff like that, all the things that S3 really loves in terms of being, delivering performance storage. Firehose is a great way to kind of employ those tools to land in that ideal format, so that you can very efficiently operate against data moving down the line. Okay, so that's sort of the kind of the real-time ingest pattern using Kinesis to get your data into S3. We also see customers often using S3 event notifications to trigger Lambda functions or other code that sort of takes data through a transformation pipeline, again, based on S3 event notifications. What S3 event notifications is they are basically events that trigger based on S3 API calls that you specify. So you can basically set on a prefix within S3, say, hey, any put object call that occurs within this prefix, hey, go trigger this Lambda code that then loads, kicks off an ETL job and start to move data through the pipeline into my sort of production data lake state, right? So customers do that all the time, sort of chain together these Lambda functions in order to prep and transact and ingest data in order to get it into that sort of proper final state that they want to land in, so that they can go run analytics against their stuff. Okay, so that's the second one. And again, sort of two common patterns that we see, one on the real time and then one on sort of the chain, sort of event-based approach to moving data through the pipeline into its final state for analysis. Okay, now I'm going to talk a little bit about how to secure your data and some of the features that we have that you can use in order to do that once it's sitting there in the lake ready to go. Okay. First thing I want to talk about is S3 access points. Access points are really designed for shared data sets. They're designed specifically for this use case of running data lakes on S3. What an access point is, it's effectively a custom endpoint that you can stand up on your bucket. You can put as many as you want, up to 1,000 within a region on your buckets. And so you can sort of carve up a bucket and vend out a custom endpoint to each stakeholder in the environment that needs to access your data. Now, the benefit of doing this is that you get to write a full 20K access policy for each one of those access points. So you're able to be very expressive into how you define the permissions for that stakeholder that's accessing your data. You can do things like pin your access, pin an access point to a VPC. And they're also ephemeral. So if you if you want to take away access to your data lake, you can just remove the access point. And from the perspective of the client set of clients that were using that route into your bucket, effectively the bucket is just gone to those clients. So it's a really nice way to carve up and vend out sort of slices of a bucket out to various stakeholders in your environment. We also have a feature called block public access. Data lakes are very commonly private. They're very commonly sort of not meant to be shared out to the public internet. Block public access allows you to control access to your data in a very easy way. It's sort of that blunt instrument that allows you to go say, hey, no public access to these buckets. You can apply block public access at the bucket level, so on a bucket by bucket basis. You can also apply block public access at the AWS account level. The best practice that we recommend is that you take all of the buckets that need public access, like that are hosting website content and stuff like that, put them in dedicated AWS accounts, and for everything else, apply block public access at the account level, and then set up service control policies at the org level to ensure that your block public access settings on those accounts are never changed. I talked a little bit about object tags for the purpose of storage management in a previous slide. I also want to call out that object tags can also be used for access control. So you can write bucket policies that say, hey, principal XYZ only has access to objects that are tagged in this certain way, right? So again, as I mentioned, a few slides back, as you're loading stuff into your lake, tagging objects up as you're touching them, as you're putting them into the data lake, can also have these sort of security management benefits as well down the line, because now you can go write access policies based on that tagging that you did up front. The last feature that I'll talk about here is called object lock. Object lock delivers immutability for your objects, allows you to apply delete protection so that objects can never be deleted until a retention period that is in object metadata runs out, right? So you can say, hey, this object should not be deleted for 7 years, and then any attempt to delete those objects will be blocked, right? So it's a cool sort of retention management feature that we have in S3, and it happens down at the object level, which is pretty cool and convenient. Okay, so those are sort of the security features that I want to call out. We got a bunch more. Again, it's another one of those topics that there's a ton of content out there from past reInvents. If you want to dive deeper into security, S3 security, highly recommend that you go take a look at that stuff. One more thing on the security side is encryption. We have a bunch of encryption options that you can go take advantage of. We have the ability to encrypt in transit according to policy. So you can write a bucket policy that says, hey, this bucket only accepts HTTPS connections. That's a very simple policy to write and enforce. That's on the encryption in flight side or the encryption in transit side. For encryption at rest, we have a couple of options. We have server-side encryption options where you can flip a switch and sort of delegate it to us. We call that SSE S3. That's Amazon S3 managed encryption keys. Or you can rely on encryption keys that are managed by the AWS Key Management Service, or KMS, right? So at the bucket level, you can sort of flip that switch either way that says, hey, I want my stuff encrypted with keys managed by S3 or keys managed by KMS. You also have the ability to encrypt client side and to pass a key in with your object. We call that client side, or SECC encryption, which is a customer provided key capability. Okay, and that's all features. The SECC stuff is all features that exist within the SDK itself. If you want to manage encryption in that way, client side. Okay, so now I'm into the sort of the last piece of the process. We've made our storage configuration decisions. We've ingested based on either sort of real time, batch or bulk ingestion methods. We've sort of transacted that data through a series of steps, right? Either using the kinesis family or S3 event notifications to drive Lambda functions to take us through that process, which means we've prepped our data for analytics. We've then secured that data using a bunch of S3 security features, and now we're going to go to the last step, which is making this stuff, making it available for use by analytics applications. And there are really two sort of camps on how to do that, right? The first is sort of a lift and shift method for running applications, where you bring a partner application from someone like Databricks or Qubel or Informatica or others in order to actually run the analytics against data sitting in S3. We love these partners. We do a ton of work with them. We're always on the phone talking about these partners. Customers get a lot of value, with this sort of lift and shift method. And the benefit is, if this is what you were doing on premises, it's a quick jump into S3, using the same sort of business processes and analytics capabilities that you had on-prem, just realizing sort of the power of scalable S3 storage. Your other option is to go the AWS managed route, using sort of these serverless platforms like Redshift, Glue, EMR, and Athena. These are AWS services that are fully managed, right? Allow you to go in using our APIs and using the AWS Management Console, and allow you to focus more on sort of data outcomes rather than the underlying infrastructure to get your analytics apps up and going. So sort of two roads that you could go down in order to get analytics going against the data in S3. And sort of two very different ways of managing those those analytics applications. Again, from an S3 perspective, we work very well with both to get you the best outcome that you're looking for over time. That's sort of the process from end to end, from setup all the way down to analytics. One more thing that I just wanted to point out to you is a service that we have called AWS Lake Formation that helps you to take you through that entire process in a very sort of managed way from end to end, right? So that's sort of the general idea with Lake Formation. Allow you to stand up data lakes quickly, really simplifies security and security management, and put you in a position where you and your customers kind of have self-service access to data, and you're not having to think about so many of the pieces and parts. Just one last slide on some overarching takeaways. S3 is a great sort of foundation for data lakes. It puts you in a position to either leverage pipeline architectures, so that improve governance, data management, and efficiency. We talked a lot about performance and how to sort of parallelize and scale out horizontally. We talked about security and how to sort of privatize your data lake, use encryption, and to really specify access controls using access points and stuff like that, in order to make sure that you have the exact sort of access patterns that you need against your data. Okay, so if you need to learn more, there's a ton of training and certification programs out there to help you do that. And thank you.